Not that complicated. With Ava and Jacob.
Hi there, and welcome to Projectile Motion with Ava. So today we're going to cover some projectile motion, but first let's cover some basic concepts. So what is projectile motion? Well, it's any motion where the only force acting on the object is the force of gravity. And a key concept to keep in mind when solving these problems is that time is shared between the horizontal and vertical components of the motion. So now that we got some key concepts covered, let's look at a problem. So a ball is launched from the ground with an initial speed of 20 meters per second at an angle of 30 degrees above the horizontal. Ignore air resistance and takes gravity as 9.81 meters per second squared downward. So let's find the time of flight. First, let's draw out a diagram because these are really essential in really getting your visuals down and understanding the problem at hand. We have components of our velocity. We have a vertical component, which we're going to call VIY, and a horizontal component called VIX. What I like to do is write out my components initially, just so I can get the trigonometry out of the way. We know that our initial vertical velocity is going to be VI sine theta, because this is the velocity that is opposite to our angle. And then our horizontal component is going to be VI cos theta, because this is the velocity that is adjacent to the angle. Now let's start off with part one, which is time of flight. So the key concept that we reviewed earlier is that the time is the same for the horizontal and the vertical motion, so we have to keep that in mind. Let's check out our given for our vertical motion. We have acceleration, we have our height, we have our initial velocity, and we are looking for our time. Now let's go ahead and change that height to displacement because they mean the same thing in this problem. Now let's look at our horizontal information. So we have acceleration is 0 in the horizontal direction. We have our initial velocity, but that's all the information we have. And given only one piece of information, which is our initial velocity, it's hard to solve for time. So we're going to cross out that information and we're going to focus on our vertical because we have enough given information there. Now, a key thing to look at is that we're talking about downward direction, which means that we're taking downward as positive, and it's really important to set your direction straight at the beginning of your problem. Now let's go ahead and grab one of the 5 key kinematic equations, where it uses all of the variables that we already have. We have our displacement is 0, we have our initial velocity, and we already know our acceleration. So you can factor out a t from this equation, and you're going to get 2 answers for t. One where t is equal to 0, because that's another time at which our height is 0. And then we can pull that out and sub in our known information. So we know that our velocity is 20, but since we set downward as positive, we have to make our 20 a negative number. Then what we can do is isolate for time, and we're left with this equation here, which solves exactly for t, where we get t is equal to 2.04 seconds. Let's now move on to part 2 of our problem. So that is finding the max height reached. Now, the key concept to keep in mind when solving this problem is the fact that at our max height, our final vertical velocity is 0. With that said, let's write out our initial given information. So we have our initial velocity, we have our displacement, which is what we're looking for, and we also have acceleration, and we have our final velocity. So we can go to one of our 5 key kinematic equations, which is the one I am writing down right now, and we are looking for our displacement. So we can isolate for that. I like to work with variables originally, but you can just sub numbers in if you would like. Remember, keep in mind that direction downward is positive. So this negative is also important to keep in mind that is outside of the square. So that negative does apply to the whole entire bracket, and just because you square it does not get rid of the negative. So then we sub in what we already know, and we calculate our displacement, which we get is negative 5.1 meters. Now this negative is important in determining direction. And since we set downward as positive earlier, we have to make sure that we know that this negative does not mean downwards. It means upwards. This means that we can now say that our max height is 5.1 meters. Now let's go to the final part of our problem, which is finding the horizontal range. So this is the amount of distance that the particle has traveled horizontally. And we know from part 1 we have the time is equal to 2.04 seconds, which we already covered is the same vertically as it is horizontally. So let's write out our given information. We have our initial velocity, we have our time, and we also know that acceleration is 0 in the horizontal direction. So we can take this equation that is very elementary and remember that horizontal velocity remains constant throughout the entire motion, since there is no acceleration acting on the horizontal components. Now we can rearrange for displacement and just solve by subbing in our already known values. And with that, we get our answer of our range, which is 35.3 meters.
Thank you for watching Not That Complicated. Don't forget to like and subscribe.